Hello everyone, I'm back. I hope you are doing well. Today's lesson, I will show you some special advanced knowledge. If you are having a time series data, and then you want to check the forecasting, the forecasting for the next previous. So what would you do? Uh, as you know that we have some several forecasting model for we can fit for some data. For example, at the previous videos, I have shown you some models like naive, ARIMA, and ETS model. So the big question is like, what is the best model we can fit for our data? To choose the best models, we can check the accuracy of the model when we are when we are training the model and we are testing for this. So today the videos. I will show you how to do this, how to check the accuracy, and then you can choose the best model for your data. The main content for this video is include 7 steps. The, the first one is load the data, and then this step to input the data. The second one is to convert the data into the time series objects. And step 3 is we have to split onto training and test data set for your data. And step number 4, we fit for the model, and because we already have the 3 models, naive, RMR, and ETS, and then we try to fit for 3 models, and then we try to forecast for every model on the test set data. And the step number 6, we calculate the accuracies for every model. In the accuracy matrix, we use 3 metrics: root mean square errors, mean absolute errors, and mean absolute percentage errors. And then step number 7, we compare the results. In the step number 6 and 7, we can choose for the best model. Now, without further ado, let's jump into the main content. Before we try to practice in our program, we have to install 3 packages: forecast and read Excel. In our laptop, it has already installed 2 packages, and now I have to just call the packages by this code. After this, we go to the first number 1, loading the data, input the data in the R program by this code. In this video, I had used the monthly mean data for this training. Let's read this code. And now we can see this is the data. It includes 2 columns. The first one is date. It's from May 2013, and then the last year is April 2025, and the second column is the monthly mean values. This data show the fluctuation of the groundwater levels. And then let's come back to the R program. After we input the data, we have to change this original data to time series data by this code, TS data. In this course, we can see that the fluency is 12 months, and the year starts from 2013 May. Let's go to the step number 2. We need to split our data to training and test sets. I mean, split into 2 parts. For training data, for training data for the model, and then we test for this model by this course, train and test. In this course, for the training data, I use this the date from the beginning to 2023 April, and for the test, I had used the data start from 2023 May to the end, and then we try to run this course for train and for test. In here, for train and for test. After we split into two parts for the data, we fit for every model. The first one for the naive model, around this. For the ARIMA model, and we can see in when we fit for ARIMA model, it takes a few minutes because it's quite long to run the ARIMA model. Yes, and it's here, ARIMA. And the final one we fit for ETS model. In this course, the S equivalent test is mean that the time we focus with the time for casting is equal to the test, the length of test data. Step number 4 is we focus for every model. The first one for ARIMA model, run this, and the second one for ETS model. In this step, it doesn't need to forecast for nice model, because nice model is benchmark methods. So the values we are focused is not changed. It's close to the last values. So I will show you later when we have the plots for every model. And the step number 5 is to check the accuracy metric. By this course, accuracy for naive, accuracy for ARIMA and ETS, we check the accuracy for every model. Let's run every course for naive, for ARIMA, and for ETS model is here. We see fit and accuracy here, and fit for every model here. After we run this code to check the accuracies, we need to create a table for every matrix to compare the accuracies. By this course, we create a table by using 3 metrics: root mean square errors, mean absolute errors, and mean absolute percentage errors. And we are creating a matrix with 3 columns and 3 rows for every matrix, naive. And let's run this course, and we can see, print this course. In the screen, you can see this is the matrix, and this is a table to show the matrix for every model. You can see this is for naive, ARIMA, and ETS here, and for every matrix is here. The best model we show is depend on every matrix, and the lower values of the matrix is better. And then we can see in this matrix for the ETS model, it has lower values. It means that this ETS model is best fits, is better for better than other model. We can choose this model. And the next step, number 7, if you want to see the clearly in this model, in the model, the forecasting values in the plots, we can see this in the plots by using the ggplot2 package. And before we do this, we need to call the package by this code library ggplot2, and then we create the plots for every model in one class by different colors. In this course, we use the multiple layer for every model, and try to run this course. We can see. It's here, as you can see in the plots. This is the plots to show the forecast of every models, and then the uh, the black line is to show the data for training, and the test data is shown by green lights, and then for night is red light. For ETS model is shown by the pink, no, green, purple, and for the ARIMA forgot is shown by green one. As you can see, I mentioned before, for the naive model, it's a straight line. It means that this values forecasting is not changed, so we don't need to care about these values. For the ETS model and ARIMA model, it's quite different. And then we see that by compare the accuracies matrix, we can choose this ETS model is the best model for our data, for my data today. So this is all for the video today. So I hope it's useful for you. Thank you so much for listening, and hopefully that it helps you to do some tasks and to do some work in your study and or research. And thank you so much again, and hope to see you next time.